Hi, welcome to another mini lecture on pre-calculus. The topic for today is graphing an exponential function and finding its domain and range and asymptotes. We have to add that to the list of things that are asked for here. Okay, how do we do this? There are at least two ways of approaching this. One is a brute force style. Whatever function they give you, you can patiently go ahead and find points of it and go about graphing the function and finding various things about it like domain, range, asymptotes, and so on. And then the second way is try to uh, make use of all the concepts you have learned so far in order to be quick in graphing and understanding the significance of all the components here. So let's do it both ways. One is we sort of pretend as if we haven't seen this type of activities before or functions before. We just go ahead and brute force it and see what happens. So if you want to graph a function, what do? Well, you make a table, you find a list of appropriate x values, calculate appropriate y values, and then see what comes next. So here the idea would be starting with that. So we're going to make a table x, and then y is given as minus 1/4 power of x plus 3. So we are essentially working in the dark. Pick a set of x values, find a set of y values, and see if you can see any kind of a pattern to it. Typically, we go after some friendly numbers that start with 0, 1, 2, 3, and so on, and perhaps -1, -2, -3, and so on. Well, let's see what happens. We take these x values, plug in the function, and see what comes out. So 0, a quarter raised to the power of 0 will be just 1 minus 1, so it becomes -1 plus 3, which turns out to be just 2. What if I put 1 in this? Well, what happens is minus quarter to power of 1 and then plus 3. So how do we understand this? It's really just 3 minus a quarter. And if you want to simplify it, or if you want to use your calculator to find out what this quantity is and so on, that would be fine. Next number, minus a quarter to the power of 2 plus 3. Okay, at this stage you need to be careful with your calculations, and if you are doing it by hand or with a calculator, you have to be clear about what's going on here. So it's a quarter that is being squared. After that, this whole thing becomes negative, and then you're adding it to 3. So it just becomes minus 1/16. The minus is not being squared, so it becomes minus 1/16 plus 3, or let's write it like this, 3 minus 1/16. And same way here, so I'll have minus a quarter to the power of -1 and then plus 3. Well, how does that work? 1/4 is raised to the power of -1, which simply means you're flipping this fraction, so it becomes 4. And then that has to be subtracted, so this is 3 minus 4. Let me write this one the same way so that you see similar pattern among all of them. 3 minus 1. Of course, this is going to be -1 if you want to simplify. -1, -2. This is going to be plus 2. And for this one, minus a quarter to the power of -2 and then plus 3. So let's write the 3 first. Quarter to the power of -2, that minus flips our fraction, makes it 4. 4 squared is going to be 16, and then minus comes in later, so it becomes 3 minus 16, which is of course minus 13. So in all cases you see that we are subtracting something from 3. Yeah. When we go to the negative numbers, the numbers we subtract gets larger and larger, and so we are going to go toward minus infinity here. And then when your x goes toward larger numbers, this fraction becomes small, and you're subtracting smaller and smaller quantity from it. So now we have to go ahead and graph this. Well, what do you do when you want to graph this? Graphing these numbers are not going to be a very friendly activity, because it's kind of hard to see, especially on a small graph paper like this. How do you do that? Well, you use this tool which kind of automate the process for you. You can just enter this number in that field. As soon as you click on that, it will open up a space for x and a y, and you enter your numbers in it, and then it plots it for you on the graph as well. So after you have done that, it typically asks you 3 to 5 points to be drawn. Uh, when you do that, you have to go ahead and take care of the asymptote. We talked about asymptote before. As x goes to plus infinity, you see that you're subtracting smaller and smaller numbers here, and the result comes closer and closer to 3. That means you have an asymptote at 3. So the asymptote of this graph is at y equal to 3, because we are getting closer and closer to 3. What does that mean? It means I have a line here, so you have to use this tool to create a line, and after your software gives you the plot of these points, what you are going to have, for example, at 0 you're going to have 2. Software is going to graph this one for you. At 1 it's going to be 3 minus a quarter, so it's going to be close to your number 3. At 2 it's going to be 3 minus 1/16, which is even closer. At minus 1 we have minus 1, so at minus 1 we'll have minus 1, that will be here. At minus 2 we are going to have minus 13, which is way down here. So the graph that we are going to get, you use this tool for, well, I'm supposed to go through all of these points. Let me draw it again. Something like this. Okay, next question. It's also going to ask you find the domain and the range. What are these things? So the collection of x's that are acceptable for your graph is going to constitute the domain. All the x's you can have in this table for which you have a y value, these things are going to constitute the domain. If there is an x that you cannot use because the function doesn't allow it, you have to explicitly remove it. And what's the range? The range is a set of these numbers, and you want to express them in a concise way. So you have to find a way better than just circling them and saying that's the range. Well, the idea that it's a good idea that is we have an idea what the range is, but we want to be more concise than that. Suppose you ask mom or dad, where are my clean socks, and they say, well, it's in the house. Well, the that's true that your socks are in the house, but that's not going to help you all that much. So to say the range is these numbers, yeah, that's a good first step, but that's equivalent to saying, well, my socks are in the house. We need something better than that. So next best thing to get an idea of what the domains and range are, domain is the set of all x's for which we have a y value. So for 0 we have a y value, for 1, for 2, for 3, for 5, and so on. If you had the patience to go and write more of them, there is nothing that's disallowed. Everything's okay. So -1, -2, -3, the function gets bigger and bigger, but uh, everything is there. So the domain of the graph is set of all x's. All x's, all real numbers are fine. There's nothing that is left out of the game. How about the range? Well, the range is a different story. We see that we are always subtracting something from 3, so all the numbers that are below 3 are covered in the range. So our range, you notice, here's another way of describing what the range is. What values of y show up? So for example, this shows up, this shows up. All horizontal lines that cross your graph, they tell you what is in the range. So we notice that from slightly below 3 all the way down, everything is covered, but we notice that there is no value of the function that matches 8 or 7 or 6 or something. These points are out of the range. So what is the range? The range is going to be this set. What's a concise way of describing this set? You can say y less than 3, or you can say everything from -infinity all the way to 3. Both of them are fine ways of doing it. 3 itself is not a range because there is no case that 3 comes out of our calculation. So this function is kind of, the graph comes higher and higher, but it actually never touches 3 itself. Below that, all the points are covered. So how do we summarize? We say domain. Several ways of saying this thing. One is all real numbers, or we say from -infinity all the way to infinity, or sometimes they use a notation that's funny looking R. These are all ways of describing set of all real numbers. Well, how about the range? Range, we said y less than 3. This is one way of describing it. Interval notation from -infinity all the way to 3. That's another way of describing this. Okay, finding domain and range is always technically complicated, especially finding the range is going to take a lot more effort than the domain usually. And for the complete answer for this type of problems, you have to wait all the way until calculus, when you will have more tools for answering such questions. But here we are looking at rather basic function, and so it should be easy for us to figure out what the domains and range happen to be. Okay, I said at the beginning that there are two ways of looking at this problem. One is to brute force it, just sit down and patiently sketch things and come up with an intelligent guess. Well, what's a fast way of doing this thing? Fast way, we go describe functions a little bit in more detail. So again, here I have y is equal to -1/4 to power of x plus 3. I see several activities here. One is I am taking a number and taking reciprocal of it. So that's one action. I want to understand what does that do to my function. Another activity is that I have a minus. What does that do to my function? Another activity is that I am adding a 3. If I understand the effect of these actions on a graph of a function, then I can uh, give a quick answer. So, step by step, our building block is that by now we should be familiar with the exponential function 4 to the power of x. Uh, we should have no problem in quickly coming up with what the graph of this thing is. Okay, so we have to start from somewhere, and hopefully from the prior section. 4 to the power of x, at 0 it passes through 1, 1 comes to 4, and minus becomes a quarter, and minus 2 becomes a 1/16, and so on. So that is a quick starting point for us. Okay, what next? Next is, well, what if instead of 4 I have 1/4? Okay, so the idea is not to go and reinvent the wheel. We want to be quick. So what is another way of writing this that connects to that? So, well, this is 4 to the power of minus x. Next question is, if I have replaced x by minus x, what does that do to my picture? So what the quick answer is, if you change x to minus x, is as if you take a function and flip it, positive x's to negative, negative x's to positive. Essentially whatever you had here, it flips across the y-axis. So the graph of 4 to the power of minus x, which is same as 1/4 to the power of x, will be same as what we had before, except that it is flipped across the y-axis, as if y-axis was a mirror, and then we took a mirror image of that. Okay, good. Next up, what is this negative gonna do? So now I'm investigating, how about minus 1/4 to the power of x, or minus, if you wish, minus 4 to the power of minus x. Remember, 4 to the power of minus x is handled first, and then we make it negative. So if any y value is made negative, what does that do to the picture? So these are the shortcuts that are going to help you answer this problem. So putting a minus in front of graph of in front of a function, it flips it upside down. Okay, so this is flip across y-axis. Here we go from top to bottom, so flip across x-axis, or this one you can call it left to right, flip left to right and right to left, flip flip up down, or turn it upside down. Finally, what do we do here? Finally is adding a 3. Well, this is a translation. We have learned about translation. If you add a number to a function, after it's all done, it lifts it by that amount. So let's go one more step here. So if I have y is equal to minus 1/4 to the power of x, and now I add a 3 to it, what happens is that whatever graph I had before is going to be lifted up by 3 units. Lifting up by 3 units, it causes the asymptote also get lifted up. It causes the y-intercept to be lifted up. The y-intercept, so originally y-intercept was at 1, here is still at 1, flipped over, became minus 1. Now if you go up by 3, minus 1 becomes 2. So your graph becomes like this. Okay, so as you work your way up in your mathematical career and becoming a full engineer and so on, it's expected that you understand functions in a much faster way than uh, this kind of a brute force way. But you always start brute force, you get your bearing there, you kind of get your feet wet, see how it is, and then you gradually build your way up to a faster way of answering questions. So graphing exponential functions and finding its domain, range, and asymptote. Finally, of course, we set the asymptote as at y equal to 3. Try to solve the problem both ways so that you become comfortable with this kind of questions and you can answer quickly. So until next time, good luck and God bless.